Can sugary drinks cause cancer? That's a question that's been asked by researchers after a study found a link between the two.
A clear relationship between sugar and cancer.
Consuming too much sugar. A new study revealing diets high in sugar are a major risk factor for certain types of cancer.
This idea that sugar feeds cancer is a reductionist idea, and it's overly simplified.
Scientists believe 2/3 of all cancers are caused by our own bad choices like smoking and not exercising. And the granddaddy of them all, a poor diet.
100 years ago, most folks consumed only 4 pounds of sugar a year. That's this much. Now, however, the average person takes in 40 times this amount, 160 pounds of sugar a year. That's this much.
Because what you eat can literally
kill you.
There may be no sentence in cancer nutrition more controversial than this one. Sugar feeds cancer. Some people treat this like one of the most important truths that a cancer patient needs to know. Other people will basically tell you that it's a myth. What if both sides are asking the wrong question? Give me half an hour of your time, and I promise that you will see this debate with brand new eyes. Because yes, I do think that it's wise to cut down on added sugars and processed sugars, but maybe not for the reasons that you've been told. Welcome back to the Stage 4 Thriver podcast. I am so excited today because this is a topic that I've wanted to talk about for a long time. Sugar and cancer. This is one of those subjects that get people really up in a tizzy. There's so many different opinions and people are super passionate about it. One side says, sugar feeds cancer, stop eating it. The other side says, that's a myth. All cells use glucose, so sugar has nothing special to do with cancer. I don't think either one of those positions actually gives us the full picture. The truth is, there's a much more interesting conversation available to us, and that's the one that I want to have. Some of what we're covering here is genuinely fascinating. By the end, I hope the question, does sugar feed cancer, feels a whole lot less satisfying than it did at the beginning. So let's talk about this debate. What is the usual argument? Let's start with the obvious part. Cancer cells can use glucose. Many cancers show increased glucose uptake, and altered glucose metabolism is a major field of cancer research. Our knowledge of this is rooted in a discovery made a century ago called the Warburg Effect. In the 1920s, German scientist Otto Warburg, working in Berlin, studied slices of tumor tissue and measured how they used oxygen and glucose. He noticed something strange. Tumors consumed huge amounts of glucose and produced a lot of lactate, even when oxygen was available. Normally, cells use oxygen inside mitochondria to extract energy efficiently from glucose. But many cancer cells rely heavily on a faster pathway called glycolysis, converting much of that glucose into lactate. It produces less energy per glucose molecule, so cancer cells often take up more glucose while generating materials that can support rapid growth. That unusual metabolism became known as the Warburg Effect, a real and distinctive relationship between many cancer cells and glucose. Here's another way to look at it. Imagine two cars with full gas tanks. One gets great gas mileage. The other burns through fuel much faster, even though it gets less energy from every gallon. Most healthy cells are like the efficient car. When oxygen is available, they squeeze the maximum energy out of glucose. Many cancer cells don't. Instead, they rapidly burn glucose through a less efficient process called glycolysis, producing a byproduct called lactate. At first, scientists thought, why would a cell choose the less efficient option? The answer is that cancer cells aren't trying to be efficient. They're trying to grow. They're more like a construction site than a power plant. Glucose isn't just fuel, it's also raw material for building new DNA, proteins, and cell membranes. Then came another surprise. For years, lactate was thought to be nothing more than waste. Now we know it can make the area around a tumor more acidic, helping cancer spread and making it harder for some immune cells to do their job. In some tumors, neighboring cells can even recycle the lactate and use it as fuel. The Warburg effect isn't just about how cancer makes energy, it's about how cancer builds, adapts, and reshapes its environment. We can see the Warburg effect in action today anytime somebody gets a PET scan. During a PET scan, a patient is given a radioactive glucose-like tracer. As the tracer circulates throughout the body, many tumors absorb it in unusually large amounts and faster than healthy tissues. Later, they appear as bright hot spots on the scan. When we look at those hot spots, we're actually looking at the radioactive glucose inside the tumor, which leaves no doubt that we can see cancer's love of sugar with our own eyes. But cancer's appetite for glucose doesn't mean that removing sugar from your diet can simply starve a tumor. Your body regulates blood glucose tightly. Even with no carbohydrate intake, blood glucose would not fall to zero because the liver stores, releases, and manufactures glucose for healthy tissues that need it too. Cancer cells can also be metabolically flexible. Many can use other nutrients, including amino acids and fats, for energy and the raw materials needed to grow. And lowering carbohydrate intake has not reliably translated into better cancer outcomes. In one randomized brain tumor trial, a ketogenic diet lowered blood glucose and produced ketosis, but did not improve progression-free or overall survival. So what are we left with? Clearly, there's more to the story. Insulin isn't just the hormone that controls blood sugar. It's also an anabolic signal telling the body nutrients are available, and it interacts with growth and survival pathways that happen to matter quite a bit in cancer biology. Insulin is a powerful growth signal. It works alongside another growth messenger called IGF-1, and together they activate pathways that help regulate cell growth and survival. Many cancer cells can hijack these same growth signals. One prospective study followed women with early-stage breast cancer and measured fasting insulin. Women in the highest group had about twice the risk of distant recurrence and roughly 3 times the risk of death compared to the lowest group. A similar pattern shows up in colon cancer. Researchers followed over 1,000 people treated for stage 3 colon cancer, and those with the highest dietary glycemic load had the worst survival across the board, especially among participants who are already overweight or obese. So here's reason 1 to take excess sugar seriously, not because insulin should never rise, but because repeated high sugar exposure can, over time, drive chronic high insulin demand and metabolic strain. Now we can get to one of the most fascinating studies that I came across. It was published in Nature in 2024. Researchers studied fructose supplementation in mouse models of melanoma, breast cancer, and cervical cancer. The tumors grew faster. The obvious assumption would be that the cancer cells simply consumed the fructose, but that would be wrong. That's actually not the most interesting part. The interesting part is that the cancer cells themselves were actually not especially good at metabolizing fructose. It was the liver that was. The liver processed the fructose and then changed what was circulating in the bloodstream. Among the molecules that increased were lipids called LPCs. The tumor cells could then take those things, the LPCs, and use them to make the cell membranes. Essentially, it was the LPCs that were the nutrition, not necessarily the sugar per se. Now get this. In that study, high fructose corn syrup supplementation increased several of these circulating lipid molecules by more than 7-fold. So the chain reaction wasn't that the cancer cells ate the fructose and then grew. It was actually that the liver processed the fructose and then handed back something entirely different downstream. Blocking the liver's fructose pathway stopped this effect. Notably, the mice didn't need to gain weight or become insulin resistant for any of that to happen. Now, given this was animal research, it doesn't necessarily prove anything with a human tumor. However, it does teach us something very real. Nutrients can influence cancer cells indirectly, not just directly. It can come through an entirely different organ's metabolism. That's a much bigger idea than the simplicity of sugar feeds cancer. In 2025, researchers looked at a combination of glucose and fructose similar to what is found in many sugar-sweetened beverages. They were studying colorectal cancer. What they found was not simply that the cells divided faster. The glucose-fructose combination increased cancer cell movement and metastatic potential compared to glucose alone. The basic idea is that the sugar combination altered the way that the cells processed energy. That combination increased glycolytic activity and fed into another pathway that ultimately promoted greater movement and invasion. What I find so interesting is that fructose alone was not the whole story. Glucose alone was not the whole story. It was the combination that changed the behavior. And I think that this reminds us that cancer biology is not only about whether a cell grows faster. Cancer cells also have to adapt, move, invade, survive, and establish themselves somewhere else. I think that this study gives us a reason to take frequent exposure to concentrated combinations of glucose and fructose seriously enough to keep studying them.
One of the biggest ways sugar can influence the body has nothing to do with feeding a tumor directly. It has to do with inflammation. Inflammation isn't always the villain. We need it to fight infections and heal injuries. The problem is when it never fully turns off. Cancer doesn't develop in isolation, it develops in a living ecosystem, and chronic inflammation is one of the conditions that can make the ecosystem much more favorable for disease. One of the most helpful ways to think about inflammation is that it helps shape the neighborhood that your cells live in. When inflammation is chronic, that neighborhood becomes less and less hospitable for healthy cells and much more supportive of disease. That's one reason why reducing unnecessary inflammation is such a foundational goal for long-term health. At the center of inflammation is a signaling pathway called NF-kappa B, often described as one of the body's master inflammatory switches. Repeated high sugar exposure can contribute to keeping this inflammatory signaling turned up higher than we'd like. Repeated elevations in blood sugar can create oxidative stress, which can damage proteins, DNA, and cell membranes while simultaneously activating inflammatory pathways. Oxidative stress and inflammation essentially become partners that reinforce one another. Here's another one. One of the most fascinating things that sugar can do has nothing to do with calories, but one of its lesser-known effects, which is something called glycation. This is a process where sugar molecules attach themselves to proteins or fats. Over time, this creates compounds called advanced glycation end products, or AGEs. They interact with a receptor called RAGE, the receptor for advanced glycation end products, which can amplify inflammation throughout the body. These compounds can make tissues stiffer, less functional, and they can activate inflammatory signals throughout the body.
In experimental breast cancer models, blocking that signaling impaired metastatic progression. Go figure, reduce the rage, reduce the cancer. In a human cohort, over 1,000 people who developed colorectal cancer, those with the highest circulating AGEs measured before diagnosis, that group had higher colorectal cancer-specific and all-cause mortality.
Did you know that fat tissue is not just passive storage? It's an endocrine organ. Most people think body fat is just stored calories, but it's actually a living, active tissue. It communicates with your immune system and your hormones. Excess sugar intake can contribute to enlarged fat cells, particularly in visceral fat. This results in inflammation. What's really interesting is that this isn't only something researchers see in obesity. Studies have found evidence of inflamed fat tissue, even in the breast, in many women with a completely normal BMI. In other words, the number on the scale doesn't tell you how healthy your fat tissue is. The quality of the tissue matters, not just the quantity.
In one study, researchers examined breast tissue from women with a completely normal BMI, expecting to find little of interest, and found that about 39% showed inflammation in the breast's white adipose tissue. Those women also had larger fat cells, higher insulin, triglycerides, and leptin, plus greater aromatase activity in the breast tissue itself. Aromatase converts androgens into estrogen, which matters enormously for hormone-sensitive breast cancer, since fat tissue can become a meaningful local source of estrogen regardless of what the ovaries are doing. Metabolic dysfunction, adipose inflammation, and hormone biology intersect, and excess sugar can be one contributor to the dietary pattern driving that dysfunction. The bigger lesson, a normal BMI does not guarantee healthy adipose tissue. Muscle mass, visceral fat, and insulin sensitivity tell you more than the scale does alone. Okay, so let's talk about something that maybe doesn't make it into this conversation all that often: blood vessels.
The inner lining of your blood vessels is called the endothelium, and it's far more active than most people realize. The endothelium helps regulate blood flow, clotting, immune cell traffic, and nitric oxide production. Repeated high glucose exposure can impair endothelial function, which then increases oxidative stress and inflammation. Because every organ depends on healthy circulation, endothelial dysfunction becomes a whole body issue rather than simply a cardiovascular one.
In controlled research, glucose that swings up and down repeatedly produced more blood vessel dysfunction and oxidative stress than glucose that stays elevated but steady, meaning that the body responds to the pattern of exposure, not just the average. Sugar-sweetened beverages specifically have also been tied to higher hypertension risk in large population studies. Some cancer treatments already stress the cardiovascular system, so a strategy built entirely around the tumor while ignoring blood pressure is an incomplete one. Now let's talk about the gut.
Your gut does a lot more than just digest food. Think of it as a security checkpoint. Its job is to let nutrients into your bloodstream while keeping bacteria, toxins, and other unwanted substances out. Diets high in sugar may disrupt that system. They can change the balance of the gut microbiome, reduce compounds that keep the gut lining healthy, and make that barrier more permeable, or what people often call a leaky gut. When that barrier isn't working as well, bacterial byproducts can slip into the bloodstream and trigger inflammation throughout the body. Researchers are finding that one of the strongest predictors of how well patients respond to immunotherapy may not be inside the tumor at all. It may be living in the gut. In one landmark study of patients receiving immunotherapy, researchers found that people with a healthier, more diverse gut microbiome were more likely to respond to treatment than those with a less diverse microbiome. This is a powerful reminder that when you nourish your microbiome, you're not just feeding bacteria, you're supporting one of the body's most important partners in health.
The intestinal barrier and microbial ecosystem are part of the terrain, and repeated dietary inputs matter. A high sugar diet matters not only because of what it contains, it also matters because of what it displaces. It's not enough to ask, hey, what have you stopped eating? It's also asking, what's replacing that?
Let's take breakfast, for example, and picture two different dishes. One of them is a sweetened cereal and a large sugary coffee, and the other is eggs, berries, nuts, and seeds. The difference isn't just in the sugar content, it's in all of the other micronutrients, healthy fats, fiber, and protein that you are displacing when you choose a high sugar, starchy, carby breakfast. We have to think in terms of not only subtraction, but also addition. What are you missing out on? Sure, you might be cutting down on sugar with the healthier breakfast, but you're also adding in protein, healthy fat, and fiber. The goal isn't just a lower sugar diet, it's a richer one with more plants, more fiber, more protein, and more variety. I also want to jump in just for a moment and say thank you so much for watching, and if you enjoy this video, please make sure to like, subscribe, and share. I am a stage 4 cancer survivor and an integrative oncology coach, and I offer a full range of coaching packages and products on my website that you can check out below. Thank you so much. Back to the video.
We need a better way to think about sugar. From a coaching perspective, I ask 5 questions. 1. How much? A teaspoon of honey and a giant soda are not the same exposure, even if they're technically the same molecule. How is it delivered? Whole fruit and a mixed meal behave very differently in the body than a large liquid dose with no fiber around it, which is why liquid sugar is usually the first place I would look. How often? Frequency matters more than any single dessert. Someone who has a cake at a birthday once a month is in a completely different pattern than someone starting the day with sweetened coffee and finishing with dessert every single night. Sometimes the issue isn't the birthday cake, it's the constant drip. Who is eating it? An active person carrying real muscle experiences sugar very differently than someone with significant insulin resistance or someone running on 4 hours of sleep and constant stress. And finally, what's happening to the terrain overall? Insulin sensitivity, visceral fat, the liver, the gut, blood pressure, that's where the real conversation lives. Excess sugar shifts the signals circulating through your body, changes what your liver produces, shapes the dietary pattern driving your gut and metabolic health, and intersects with fat tissue, blood vessels, and your own tissue chemistry over time. That's why cutting back is wise, not just for the reason the slogan gives you, because you're not just treating a tumor, you're caring for the person who carries it. And that person deserves way more than fear or a slogan. Thank you for watching the Stage 4 Thriver podcast. I hope you enjoyed it. I'll see you next time.